an architecture that empowers complicated vision tasks such as dense video captioning and video question answering with common sense reasoning. I can see nothing, says Watson. On the contrary, Watson, you can see everything. You fail, however, to reason from what you see. This quote from Sherlock Holmes aptly describes what iPerceive is about. So without further ado, let's dive in and see what iPerceive has to offer. Introducing iPerceive, a framework that enables common sense learning for videos. Traditional pattern learning based AI systems rely on the conventional probability P of y given x, which is different from what common sense reasoning relies on. Let's take an example. If the model often sees a keyboard and mouse on a table, it learns to associate the keyboard, mouse, and the table combination. Now, during test time, if the model comes across a keyboard and mouse outside of a tabular setting, it can fall prey to a cognitive error. On the right, we've shown some examples of why this matters. So how do you go about generating common sense vectors for videos? Figuring out the cause and effect relationships between events, especially in videos, is very challenging. And particularly more so in a video compared to an image, because events in videos can overlap in time and they can have causal relationships between themselves. As shown, we perform a deliberate borrow-put experiment by borrowing an object Z from another event and putting it in the context of a pair of objects X and Y in a particular event. Now, if object X still causes the existence of Y given Z, the chance of Z is dependent on X or Y, hence establishing the causal relationship. We adopt the do calculus proposed in the cited paper and use it as a new learning objective. This helps alleviate the observational bias that makes the model commit cognitive errors. So here's iPerceive dense video captioning DVC, which performs three major functions: event proposal, common sense reasoning, and captioning. The event proposal block is where we localize events in the input video. The common sense reasoning block forms the basis of iPerceive and is where our contributions lie. The captioning block is where each modality, video, audio, and speech, is redirected to the corresponding transformer. Out comes a caption sampled word by word. iPerceive DVC thus blends multimodal DVC with common sense based learning. Next, we present iPerceive VideoQA, which accepts inputs from multiple modalities such as video, question answers, subtitles, and dense video captions. We split the flow of iPerceive VideoQA into two parts: feature fusion and frame selection. In feature fusion, we derive supplement video features with common sense vectors. We then combine all of the input modalities and feed them to dual layer attention. Under frame selection, we calculate frame relevance scores to select the correct answer from 5 candidates. Okay, now let's talk about the common sense reasoning loss. We split the common sense reasoning loss into two components: self-predictor loss and context predictor loss. Under self-predictor loss, for a center object X in the video frame at time t, we use negative log likelihood to figure out how we're doing on the center object labeling task. For context predictor loss for an object Y in the context of the center object X, we use another negative log likelihood based loss to figure out how we're doing on the context object labeling task. The overall multitask common sense reasoning loss is the summation of the two. Here's some qualitative evaluation of iPerceive dense video captioning showing better performance than the current state-of-the-art approaches. You can see that iPerceive DVC captures the subtle details in captions and has a better overlap with ground-truth captions than the other approaches. Comparisons with the state-of-the-art shows that a model furthers the state-of-the-art in most cases. So why did we choose this problem? Similar to how humans perceive the world around them by observing their surroundings visually, video is how machines interact with the real world, which is why we think that video understanding is particularly important to close a gap between man and machine. And lastly, to read more, visit us at iperceive.amanchara.com. We have a set of detailed readmes ready for you to get started. Thank you.